if the spring is not there, while we loosen this strap, the strap clamp is likely to fall downwards. So, to prevent that falling down of the strap clamp, we are providing this spring over here, which will always keep the strap clamp in going in the upper direction. It will be held upwards, and this support is there on the right hand side, which is also very important while we clamp this workpiece, because this support has to be almost equal to the workpiece thickness. But these spherical surfaces on the clamp over here and the pivot over here create the flexibility, and these strap clamps may be used for a little variation of sizes. One end of the clamp rests on workpiece surface while other on the heel pin, thus loading the clamp like simple supported beam. The clamping phase of clamp is made spherical or curved to take care of any job size variation. Generally, strap clamps are provided with a washer and a spring below the clamp. The spring lifts the clamp as nut is loosened. The workpiece becomes free from even the gravitational force due to clamp weight. The spring always holds the clamp in raised position during the loading and unloading of the workpiece. And other type of clamping system may be using the retractable clamp designs. When clamps fall in way of loading and unloading, they are made from with slot in middle to allow withdrawal, shown in figure above. So, as we have seen in this clamp before, this slot is helping retraction of the strap clamp, so that it can be withdrawn back after the operation. So, another design is your swinging clamp, because we need quick action for economy. We should be able to do our work in minimal of time. Over there we can use the swinging clamps, which are really effective and reliable when we want quick action. So, in the figure over here we can see the swinging clamp. Over here there are two positions of the clamp. This rectangle over here shows the position of the strap when the job is fastened or held strongly with help of the clamp. And if we see this rectangle in vertical direction, this vertical direction has been produced by rotating this horizontal direction by rotating it by an angle of 90 degrees. So, as we rotate this on 90 degrees, we can see there is some gap over here between the job and the strap. So, the workpiece area or the loading area is free from the strap. So, this kind of 90-degree turning of the strap is the inherent quality of the swinging clamps. In another design, in these swinging type of clamps, the clamp is rotated 90 degrees to clear passage for loading and unloading of workpiece, as it is shown in the figure. Then another type of clamps may be the edge clamps. Over here are the two examples of edge clamps. So, why these are called the edge clamps? Because these are trying to hold the job on the edges. Over here on the workpiece right hand side, this clamp is creating a force, and in the right figure there is an edge jaw clamp. We can see there is a jaw on the right hand side of the job. It is having tooth formed on the surface, that is on the right hand side of the job. So, this may create some indentation into the edge of the job, but we see that this is very effective method. And one point which is very important to note in these edge type of strapping clamps is that while we tighten this bolt nut over here, this element will be falling down, it will be tending to come in direction down in direction of this axis of this stud. So, as it is coming down, this element which is touching the job is trying to push the job onto the left hand side, so that it butts well with the reference. So, this workpiece is being pushed onto the left hand side, and also as this element goes downwards, it is also pulling the job work or the workpiece downwards, so that it butts well on the surface of the table. Similarly, on the right hand side, this jaw is pushing the job onto the left hand side as well as pulling it down. So, in this kind of design of edge strap clamps, we are easily able to do machining on the top surface of the workpiece. If we put any clamp over the surface, that will produce an hindrance for operation on the top surface of the workpiece. For example, in case of surface grinding, we will require to grind the surface, whole of the surface of the workpiece in a single go, and we do not want any obstructions due to clamping. So, in that case, edge strap clamp is more effective and a clear way of working for the whole of the surface in a single go. So, figure above shows simple edge clamp. These are suitable for clamping workpieces to do milling on edges. In second figure, the clamp slides on inclined heel as hexagonal nut is tightened. Then according to the design, what kind of operation we require on the job, we may design the straps or the clamps in a special way. So, we are just about to discuss the special strap clamps, and in the figure you can see a strap clamp which is having some recess over here on the top. Because this milling cutter is coming in the way, it has to do some machining in the job into the job to certain extent, and that is why this recess on the clamp is kept, a C type recess is kept, so that this milling cutter wheel can enter into this slot, so that it can do the machining well. So, at this in this case, it is clamping on two sides, left hand side and the right hand side, and so this is a special type of strap clamp. Or it may be having a spider kind of clamp which is having three elements over here. This is number 1 element, this is number 2, this is number 3. So, with these 3 elements you can fix up maybe about 3 jobs, one over here, second over here and third over here. So, simultaneously we are fixing 3 jobs, or maybe it is doing on a single job, but it is butting on 3 surfaces of this spider over here, 1, 2 and 3. So, these are special strap clamps. In figure above, it is shown that shape of clamp is changed to suit workpiece and operation. In milling fixture, clamps are often slotted in middle to allow passage of cutter. Then another type of clamp designs are the pivoted clamps, which we have earlier discussed. We will discuss this again. So, in case of pivoted clamps, one feature that is there is the pivot. So, we can see in this figure the pivot is in the middle over here. Over here we can see it is on the middle over here for the clamp, and the clamping element is having 2 sections or 2 sections which are at about 90 degree to each other. In this figure over here we can see a pivot again, and the pivot is not in middle of the job, it is on to the right hand side of the job. And in the figure number 4 you can see another pivoted clamp. It is pivoted at this position, and this type of clamp is having 2 elements which are at 90 degree to each other. So, the functioning of these types of clamps is quite evident from the figures itself. As you tighten this knurled knob over here over the screw, this screw will be driven downwards, and as it is driven downwards, this element is going to be raised while this element is going to come down on the workpiece. So, it is swinging about this pivot point. So, it is creating a lot of flexibility over here. So, the job may be thick or thin. A large variation in size, thickness size of the job can be handled with this kind of pivoted strap clamp. Over here, this is a special type of strap clamp. Over here again, it is clamping from the edge of the workpiece. So, if we study this minutely, as this hexagonal nut is tightened, this element will go towards right, and similarly this jaw end of the clamp will be forcing the job onto the left hand side, and it will be slightly pulling the job downwards as well, so that it butts well on the table. And similarly, you can understand very well on the right hand side the two figures. These are self explanatory, and so these are the special types of clamps over here. Clamps are often pivoted at center or simply to simplify their operation. The figure above shows pivoted clamps. These are sometimes loosened and tightened, sometimes with help of knurled head. The clamp pivots around the center during operation. Pivot action can be used for two-way clamping of workpiece. Tightening the knurled screw first pushes the workpiece till it touches the locator, and further tightening the screw pivots the clamp in anti-clockwise direction till curved surface of clamp touches down on the workpiece. Further tightening of knurled head clamps the workpiece in vertical and horizontal direction. Thus, a two-way pivoted clamp pushes workpiece against two locators before it clamps workpiece simultaneously in two directions. So, next design is the hinged design. In hinged design, we provide rapid clearance of loading and unloading passage. For loading or unloading of workpiece, the hexagonal nut is turned half a turn and swung out of open slot. To free the hinged plate, as shown in figure, a hinged clamp can also be used for two-way clamping, as shown in figure. Tightening of knurled nut against hinged clamp first pushes clamping pad towards workpiece, which is clamped simultaneously in two directions by edge clamp and the pad in the hinge. So, over here you can see a hinge on the right hand side. This is the clamping element which goes down, and there is a hinged bolt on the left hand side. So, this element which is swinging onto the hinge over here on the right hand side gets fixed under this bolt. So, as we tighten this, so this will be the position. So, under this hinged strap, the job has been fixed down, and because we are using a pivot point in this one, this program, we can see the job has been fixed on two sides, on the left hand side and the right hand side. So, this is the equalizer over here. So, we will be able to hold a job with odd geometry, or maybe we can use the same mechanism for holding two jobs simultaneously, or we can hold two jobs simultaneously with different thickness of the jobs. The next is your swinging clamps. So, in the figure over here, swinging clamps have been shown, and the important feature of these swinging clamps is after the job after the operation has been done, this clamp can be swinged into the right hand direction or the anti-clockwise direction to make the area free for the job to be removed and the newer job to be fixed again. If we see in the front view over here, this knurled head over here is rotated in clockwise direction so that the screw goes in downward direction to touch the workpiece and further tighten the workpiece on the left hand side. So, similarly we have this kind of swinging clamp which is shown in the top view and the front view. We can see this element is having a swinging action over here. This is the locked position, and if we rotate it by 90 degree, it will free the job, and then you can freely remove the job from the place for fixing up second job. Like hinged clamps, swinging clamps must be swung in working position. However, in swinging clamps, the axis of rotation is square with clamping plate face. The loading and unloading of workpiece, the clamp is swung aside as shown by dotted lines position. So, I hope you are benefited by this lecture on clamps, on the clamping systems. We definitely need these type of clamping systems for carrying out the machining operations, or maybe for the assembly of the different components, or many times for painting as well. So, if we discuss further, we can discuss regarding this quick action clamps. The advent of mass production has resulted in development of several quick clamping gadgets. So, one of these quick action gadgets is the C washer. So, C washer is simple and quick in operation. The C washer is strap clamp with an open slot as shown in figure. The slot permits removal of C washer. After a slight loosening of hex nut, loss of washer can be prevented by chaining it to the fixture, or else it may be made with a captive C washer, which is shown in the figure. So, captive word is used over here because the C washer has been captivated now, it cannot be lost now as shown in the figure over here. So, this C washer can be rotated anti-clockwise in position while it has locked the job, or when the job has been done, this C washer, the captive C washer, will be rotated in clockwise direction so that we can remove the job. This is as shown, the C washer over here on the left hand side is the simplest form of quick clamping system, and over the top is various types of latches. We can see a hole is there. So, a bigger hole with this is a regular slot over here, but on the right hand side if you see, the hole is bigger, and for the second slot again the hole on the right hand side is bigger. So, as you push this latch onto the left hand side, it will be aligned with the bolts will be aligned with a bigger hole, so that you can pull this strap upwards and free it from the bolts. And on the right hand side you have these strap clamps which is simultaneously clamping on the left hand side and the right hand side for the two jobs. So, this is also one of the quick methods of clamping, and another one is shown in the figure over here. The direction of the recesses, the C type of recesses is different. They are in 90 degree to each other. This C recess is in 90 degree to the recess in over here in this location, in this position. So, other systems which are used for clamping are the different types of cams. So, you can see in the figure there is an eccentric clamp, and in this you can see a handle is there which is to be rotated either clockwise or anti-clockwise. So, over here it is shown while you move it into clockwise direction, it will be clamping the job because it is eccentric, and if we move the handle onto left hand side or the anti-clockwise direction, the job will be clamped. So, this is because of the eccentricity of the cam, and similar use is shown on the right hand side. So, this is a very quick and effective method of forceful clamping, where we require large forces and the action of loading and unloading and clamping should be with high forces. We can use this eccentric type of clamping systems. So, in another figure we are seeing this eccentric cam on the right hand side. It is quite self-explanatory how this is operating. So, these nuts have been tightened permanently in this position for this kind of a job, for this kind of thickness of job. So, as we operate the cam over here, the eccentric cam, the job on the left hand side is clamped, and we can go on further, but I believe the time for the lecture is over. I hope you are benefited by this lecture, and see you again very soon. Thank you.